Hi guys, it's Simon C. Welcome to this new AI radar. Today I have 3 articles about advances in artificial intelligence. The Daegu Book Institute of Science and Technology in Korea announced at the beginning of July that Professor Min Soo Kim's team in the Department of Information and Communication Engineering developed the DistME, Distributed Matrix Engine technology, that can analyze 100 times more data 14 times faster than the existing technologies. This new technology is expected to be used in machine learning that needs big data processing of various industry fields to analyze large-scale data in the future. Professor Kim's team developed a distributed matrix multiplication method that is different from the existing one, also called cuboid MM. This method forms matrix multiplication in a 3D isohedron, a 6-phase polyhedron, and then partition and processes to multiple pieces called cuboids. Cuboid MM not only includes all the existing methods but also can perform matrix multiplication with minimum communication cost. In addition, Professor Kim's team devised an information processing technology by combining cuboid MM with graphics processing unit, and that dramatically enhanced the performance of matrix multiplication. Specifically now, the processing speed by this combination is 6.5 and 14 times faster than SCALA Pack and System ML respectively, and can analyze 100 times larger matrix data than System ML. It is expected to open new applicability of machine learning in various areas that need large-scale data processing, including online shopping malls. Sam Million-Weaver reports that the University of Wisconsin-Madison engineers have devised a method to create pieces of smart glass that use light to recognize images without requiring any sensors or circuits or power sources. They basically embedded AI into inert objects, an advance that could open new frontiers for low-power electronics. For example, in the future, one piece of smart glass in your smartphone could recognize your face to unlock it with Face ID without AI draining the battery. Smart glass could be also useful in more complex tasks such as facial recognition. So you point your face onto the smartphone screen and the AI makes the rest. In particular, tiny strategically placed bubbles and light-absorbing materials like graphene at specific location inside the glass would bend light in specific ways to differentiate among different images by means of artificial intelligence. The process is similar to machine learning training, except that the engineers trained an analog material instead of digital codes. For their proof of concept, the engineers devised a method to make glass pieces that identified handwritten numbers. Light emanating from an image of a number enters at one end of the glass and then focuses to one of 9 specific spots on the other side, each corresponding to individual digits. The glass was dynamic enough to detect in real time when a handwritten 3 was altered to become an 8. Hence, the computation is completely passive and happens in the material, so that one piece of image recognition glass could be used hundreds of thousands of times. Additionally, it works at literally the speed of light, because the glass distinguishes among different images by distorting light waves. Although the upfront training process could be time-consuming and computationally demanding, the glass itself is easy and inexpensive to fabricate. Jordana Cepelewicz on Quanta magazine reported that a research team in Germany found that ImageNet trained convolutional neural networks often fail at classifying images because strongly biased towards recognizing textures rather than shapes. The ImageNet project is a visual database of 14 million images designed for use in visual object recognition software research. So basically, images that are even a little novel, noisy or grainy can throw off deep learning systems completely. So while humans pay attention to the shapes of picture objects, deep learning computer vision algorithms routinely latch on to the object's textures instead. To come out with their results, the researchers thought about what quality changes the most with even small levels of noise. Texture seems to be the obvious choice. The shape of the object is more or less intact if you add a lot of noise for a long time, said Robert Gayros, a graduate student in Betges and Wichmann's labs, and the lead author of the study. But the local structure in an image that gets distorted super fast when you add a bit of noise. The fact that artificial intelligence prefers texture over shape makes sense. You can think of textures as shape at fine scale, said Nicholas Crickescourt, a computational neuroscientist at Columbia University who didn't participate in the study. That fine scale is easier for the system to latch on to. The number of pixels with texture information far exceeds the number of pixels that constitute the boundary of an object, and the network's very first steps involve detecting local features like lines and edges. This peculiarity of ImageNet-trained convolutional neural networks and AI vision in general is also what makes deep neural networks prone to adversarial examples, though a deep flaw indeed. Their over reliance on color, texture, and background cues. Watch AI Radar 44 to learn more. In the paper accompanying their research, researchers point out that increasing shape bias improves accuracy and robustness though. Whoa, that was long. Okay guys, it's all for today. See you next time with AI Radar. Bye.